Today I will be talking about Newton's three laws of motion. And today I will start off with talking about Newton's first law of motion, or the law of inertia. An object that rests will stay in rest, and an object in motion will stay in motion unless acted upon by another force. So the first example I have here is a tennis ball, and as I give this ball a push, I am exerting outside force to the ball, causing it to move. It will stay at a constant velocity but eventually slow down due to friction. And my second example I have here is a penny and a cup. So as I pull this card horizontally, the penny will fall into the cup due to gravity. So let's try it. Yes, it worked out. And the gravity is acting as an outside force that will bring this penny to go down and at rest. And this is also an example of inertia. Okay, so now we're going to talk about Newton's second law of motion, where F net equals m times a, and F net is equal to net force, and m equals mass in kilograms, and acceleration is meters per second squared. So this basically means that an object's acceleration is inversely related to its mass and directional proportionate to the net force exerted on it. And the first example I'm going to do right now is water resistance and drag. So as I move my legs in the water, I encounter water resistance, and this is an example of Newton's second law, where the force required to push through the resistance of the water I'm experiencing right now depends solely on my mass and the amount of acceleration I apply to it right now. So the second example I have here is pushing a floatable, and as I push this floatable, it will move towards the direction that I pushed it, and this is an example of Newton's second law, because the acceleration of the floatable depends on the net force and mass of the floatable. A lighter one requires less force, and the heavier one requires more force. Okay, so now I'm going to do Newton's third law, and the third law states that for every action there's an equal and opposite reaction. So first example I have for the third law is a tennis ball again, and when I bounce my tennis ball, the ball exerts the applied force to the ground, and the ground exerts an equal and opposite force on the ball, making it come right back to my hands. Okay, so now I'm going to talk about Newton's third law, example 2, pushing a ball in the water. Okay, so this one, as I push the ball in the water, I am exerting downward force that is breaking the resistance of the water right now. And when I release it, the ball comes flying back up with the opposite force due to the water. That's an example of Newton's third law. Okay, so why Newton's laws are important. Newton's laws of motion play an important role in both classical mechanics and everyday life. Newton's laws provide us with the foundations to mechanics and allowed us to understand the interaction between objects and motion. From the movement of our body to the safety and design of our homes, Newton's three laws of motion comes in play. His law explains the mechanics behind muscle movement, which is crucial to everyday lives, and the design and build of our homes to ensure safety, because the design will have the amount of force exerted to an object to maintain balance of our homes. In conclusion, Newton's three laws provide insight into the mechanics of our everyday lives and the complex mechanics that occur in our universe. Thank you.